Did you know there is a small object, no larger than the palm of your hand, yet it quietly consumes more than 1/3 of your lifetime? Not gold, not luxury items, but the very iPhone you are holding right now. Behind its minimalist exterior lies an incredibly complex production journey. From extracting bauxite to produce the aluminum frame, to manufacturing the screen in a space-grade cleanroom, every single iPhone must go through hundreds of precise and sophisticated steps before it finally rests in your hand. In today's video, we will take you from A to Z through the entire iPhone manufacturing process. Join us as we uncover the secrets behind the iPhone you use every day and discover why its level of craftsmanship has earned admiration from people all around the world. When it comes to smartphones, one name inevitably stands out: Apple, the technology titan that has transformed the world with the iPhone. Since its debut in 2007, the iPhone has not only redefined the smartphone industry, but also generated immense economic value. Today, the iPhone accounts for more than 50% of Apple's revenue, making it the highest-grossing consumer product on the planet. Before reaching your hands, every single iPhone must survive over 800 rigorous tests, a journey in which a failure at any step results in the device being immediately removed from the production line as if it had never existed. The iPhone is more than just a phone. It is an icon that has sparked debates worldwide for over a decade. Some say it is expensive, others call it unreal, yet no one can deny that this tiny device embodies prestige, design sensibility, and even the lifestyle of its owner. At the bauxite mine, the extraction process begins. To break through the hard layers of ore, engineers perform controlled drilling and blasting, releasing the bauxite from the parent rock. Massive excavators and haul trucks move continuously, digging and transporting the ore from the surface layers down to the collection site. The ore is then conveyed along long belts through high-capacity crushing systems, where it is sorted and separated from impurities. Each fragment of bauxite is thoroughly washed, purified, and prepared for the next stage in the aluminum production journey, where heat, chemicals, and electrical energy will transform the raw mineral into pure metal, ready to be reborn as the aluminum frame of modern iPhones. Once it leaves the mine, the bauxite enters the processing plant, where high temperatures and intense pressures awaken the metallic potential hidden deep within the earth. In a caustic solution, the ore dissolves, leaving behind alumina, a pure snow-white powder. Yet this is only the beginning. The alumina is melted in massive electric currents of thousands of amperes, separating oxygen and generating pure aluminum, a lightweight, bright, and durable metal. From the first droplets of molten aluminum, flawless alloy sheets are produced, ready to move on to the next phase, forming the iPhone's body, where raw materials are transformed into the foundation of advanced technology. When molten aluminum solidifies into the first sheets of alloy, they are ready to enter the process of shaping the iPhone frame. Here, high-speed milling machines carve out every minute detail with precision down to the thousandth of a millimeter, producing iPhone frames with absolute accuracy. As the milling cutters carve and shape the aluminum frames, an enormous amount of heat is generated, which could potentially deform the material or dull the cutting tools. For this reason, water or specially formulated cooling solutions are continuously sprayed throughout the machining process to maintain stability and precision. Once the backbone has been mechanically shaped, the process moves into an entirely different realm, a world of ultra-pure materials and nanotechnology. After the chip design is finalized, the production of the processor, the device's brain, officially begins. In this stage, absolute precision is critical. Even a single speck of dust or a deviation of a few micrometers is enough to render the entire component useless. Within high-level cleanrooms, lithography machines worth hundreds of millions of dollars use ultraviolet light to etch ultra-thin circuit layers onto the surface of silicon wafers, creating billions of transistors on an area no larger than a fingernail. To ensure the iPhone operates reliably, the battery is an indispensable component. In Shenzhen, China, the Pisen production lines manufacture thousands of batteries every day with precision comparable to chip production. The process begins with two thin metal strips, aluminum and copper, coated with lithium cobalt oxide and graphite, then fed through a long furnace with multiple temperature zones in a completely dust-free clean room. During the battery pressing stage, the plates, already filled with electrolyte solution, are placed on a heated platform. A hydraulic press descends with pressure calibrated to the Newton, distributing the electrolyte evenly and compressing the electrode layers. Even a small deviation can cause the battery to swell, degrade prematurely, or explode. Before leaving the factory, each battery undergoes a Hell test. Thermal shock chambers cycle the cells between 20° and 80°, followed by dozens of continuous charge-discharge cycles to detect voltage drops, swelling, or increases in internal resistance. Only batteries that survive all these rigorous tests are labeled, packaged, and released, ensuring safe and stable operation for many years. If the battery serves as the power source, then the main display is the surface of extreme precision, where even the slightest deviation of just a few microns is enough to render a component unusable. The journey begins with raw glass panels immersed in chemical baths where high-speed spinning discs apply a uniform coating, which may serve as anti-glare, fingerprint-resistant, or hardness-enhancing layers. The rotation speed and solution viscosity are carefully controlled to ensure the coating is applied with micron-level precision. After coating, the glass panels pass through a multi-chamber washing system using different cleaning solutions ranging from ultra-pure deionized water to ion-removing agents and ultrasonic baths. This process eliminates dust, impurities, and any excess coating. A single remaining particle is enough to discard the entire panel. Once the surface is perfectly clean, the glass is dried using hot air streams and then transferred to CNC or laser cutting machines. Robots precisely align each panel in fixed positions, and high-speed cutting blades shape features such as 2.5D curved edges, earpiece holes, camera placements, and sensor openings. Any deviation of merely 0.05 millimeters results in immediate rejection of the product. Once all components have been fully prepared, the assembly line enters its most critical phase, a stage in which even the slightest error can lead to severe consequences, ranging from a faulty screen, short circuits, to the risk of battery failure or explosion. At this point, absolute precision becomes a matter of survival. The process begins with the placement of the main circuit board, which houses the CPU and memory, into the device chassis with micron-level accuracy. The circuit board must be perfectly secured to ensure seamless connections with other components, without any deviation. Once the board is stabilized, the display is mounted using vacuum suction technology, which holds the screen firmly in place while preventing any dust from entering. Immediately afterward, ultra-fine data cables connecting the display, sensors, and circuitry are attached by robots, guaranteeing that each electronic connection is stable, secure, and perfectly aligned. Next comes the installation of the battery, the camera module, and the vibration motor, components that are highly sensitive to their surrounding environment. A single speck of dust entering the camera can create bright spots in images, completely compromising the photographic experience. This entire procedure is performed entirely by robots, from positioning components and soldering connections to inspecting circuits and final calibrations. These robots operate with precision down to thousandths of a millimeter, ensuring every component is exactly in place, minimizing risks to the lowest possible level, and maintaining the highest standards before the device leaves the production line. Observing the entire assembly line, it becomes clear that every iPhone is the result of a delicate orchestration between mechanics, automation, and quality control. Every action, every connection matters, and even the smallest error can render the entire device inoperative. This is a testament to the meticulous craftsmanship, scientific rigor, and cutting-edge technology that lies behind the smartphones we use every day. Once the physical form of the iPhone is fully complete, it enters the quality control stage, the critical phase that determines whether the product meets the high standards required to reach the hands of users. At this stage, technology and human oversight work in tandem to detect every flaw, no matter how small. Automated robotic systems perform a series of technical inspections, from touchscreen sensitivity, camera performance, and audio output, to network connectivity and processing efficiency. Even a single deviation beyond the allowed threshold results in the device being immediately removed from the production line. In addition, each iPhone must undergo drop tests, during which the device is released from various heights onto different surfaces to simulate real-world impacts. High-speed sensors and cameras record every effect, verifying whether the screen, frame, and internal components can withstand the forces of impact without damage. Following that, the devices undergo water and dust resistance testing according to IP standards. Each unit is exposed to mist, immersion, or direct water sprays to ensure the enclosure effectively prevents the intrusion of liquids and dust. Only those iPhones that successfully pass all of these rigorous tests are allowed to move on to the packaging and shipping stage, guaranteeing that the user receives a flawless, durable, and safe product. Once an iPhone has successfully passed hundreds of rigorous tests, it enters a stage that may appear simple at first glance, yet is astonishingly sophisticated: packaging. Each pallet containing hundreds of iPhones must have its weight perfectly balanced to prevent tilting or shifting during air transport. This meticulous attention to detail is precisely why iPhones rarely arrive damaged in the hands of users. Every shipment is packed with the precision and care of a military-grade cargo operation. And as the iPhone leaves the factory, the journey of another essential accessory begins: the phone case. If the iPhone represents cutting-edge technology, the case serves as its silent armor, providing protection against scratches, drops, and the wear of daily life. The process begins with raw polymer pellets, TPU, PC, or silicone, which are carefully measured and fed into high-precision injection molding machines. These machines heat the material to the exact temperature needed for perfect flow, then inject it into metal molds that define the case's exact shape. This initial form then enters a series of meticulous finishing steps. Trimming removes any leftover flash, edges are rounded, and the case is polished to create smooth curves that hug the contours of the camera module, buttons, and speaker openings. Every detail is sculpted to ensure that the case will fit flawlessly onto the iPhone, providing both protection and ergonomic comfort. Once the physical shape is perfected, the surface of the case is transformed with UV printing, color coding, or decorative patterns. Each layer of ink is applied in a delicate mist, then cured under ultraviolet light to create a durable, fade-resistant surface. For transparent cases, an additional anti-yellowing coating is applied, preserving clarity for years of use. From the first molten pellet to the final polished, printed surface, every case is a testament to precision engineering, meticulous craftsmanship, and the seamless integration of technology and design, ensuring that the iPhone is shielded in style while maintaining its aesthetic perfection. For more than 10 years, the global smartphone market has been a relentless arena of technological competition, with the iPhone standing firmly at its center. Every rival, from Samsung and Google to Xiaomi, has continuously tried to challenge Apple's dominance, seeking to claim the crown for themselves. Yet despite the intense pressure, the iPhone has preserved its unique position, built on a seamless ecosystem, industry-leading chips, and manufacturing standards so precise that even a single micron matters. Apple's devices are more than just tools. They are symbols of craftsmanship and loyalty. Users don't just buy an iPhone. They invest in a philosophy, a lifestyle of simplicity, elegance, and precision. Meanwhile, competitors push forward with open systems and unlimited customization, embracing a different vision of what a smartphone can be. This clash of philosophies, freedom versus refinement, is what fuels one of the most fascinating rivalries in the modern era of technology, shaping the devices millions of people rely on every day. From raw aluminum sheets to processors containing billions of transistors, from ultra-thin displays to batteries monitored, down to the milliamp, every single iPhone undergoes hundreds of stages of fabrication, inspection, and assembly with near-perfect precision. Behind the sleek exterior that rests in your hand lies an enormous technological ecosystem, where robots, clean rooms, and exacting standards operate continuously to produce a device that is stable, durable, and meticulously refined in every detail. And that is the complete journey of an iPhone, from raw materials to the finished product. Which iPhone model are you using right now? And what feature do you find the most impressive? Leave a comment below to share your thoughts and experiences, and don't forget to like this video, share it with your friends, and subscribe to the channel. By doing so, you'll stay up to date and continue exploring even more fascinating technology stories, behind-the-scenes processes, and cutting-edge innovations in our upcoming videos.